Let's try lecture problem 12.3. In the United States, railroad cars ride on steel rails. Until the mid-1900s, most track consisted of 11.9 meter lengths connected with expansion joints that allow for the rails to expand and contract with temperature. If a section of rail is exactly 11.9 meters long on a hot sunny day when it warms up to 50 degrees Celsius, how long will it be on a cold 10 degrees C winter morning? Okay, so first we should just write down the equation for linear expansion. So the change in length is going to be equal to the coefficient of linear expansion times the initial length times the change in temperature. So if you notice, the first thing we need to know is this alpha right here, which is the coefficient of linear expansion. And if you go over to table 12.3 in your book, you can find that alpha is going to be equal to 12 times 10 to the negative 6 times 1 over Kelvin. Okay, so now we know alpha, we know the initial length, right? 11.9 meters. And we know the change in temperature. So it's going to go from 10 degrees C to a final temperature of 10 C. And so this delta T is equal to the final temperature minus the initial temperature, which is going to be equal to, final temperature is 10 minus 50, and this is equal to negative 40. And again, since it's a change in temperature, Celsius and Kelvin can be thought of as the same. So negative 40 K. And we have to make sure we're in Kelvin because these constants are all given in Kelvin. And so now we can pretty much just fill in. Delta L is going to be equal to alpha, which is 12 times 10 to the negative 6 times 1 over Kelvin times the initial length, which is 11.9 meters, times delta T, which is negative 40 Kelvin. If you notice, this is going to come out to a negative, which means that this beam is going to shrink, which makes sense, right? Because it's going from a warm temperature to a cold temperature. And so we would expect it to shrink, so that's good. So this is equal to, if you notice, our Kelvin is going to cancel out, and we're just left with meters. And this comes out to negative 0.0006 meters. And so this is going to shrink a lot. I mean, it's not going to shrink a lot, right? 0.006 meters. So it's just 6 millimeters. So even though it's a really small amount, when you engineer something like railroad tracks or something, you have to take into account this. But we're not asked for how much it shrinks. We're asked how long will it be on a cold C winter day. So all we have to do is the initial 11.9 meters minus 0.006 meters. That's how much it's going to shrink. And this comes out to 11.894 meters. So it shrank, but not very much. And that's lecture problem 12.3.